So first, already we discussed about that stop and wait protocol for noisy channel. So when it is noisy channel, there is every possibility of the information that is being transmitted may be received with errors. So at the receiver side, the information may be received with errors. So the receiver has to verify these errors. If any errors are there, it has to ask for the retransmission. So that procedure we will see in this, and based on that, three protocols are there. So stop and wait for the noisy channel with automatic repeat request, go back and with automatic repeat request, select to repeat with automatic repeat request. So these are the three, we'll see that. So basically, what will happen in the noisy channel, how the communication is being taking place. So first step is, now the information, so from the network layer, the request comes to the data link layer. At the sender side, the data link layer of the sender side will get the request from the network layer about the information transmission. Then the data link layer will get the information from the sender network layer and prepares the frame. Then frame will be sent to the physical layer. Then physical layer will send as bit stream to the receiver. So after that, the data link layer at the center will be waiting for the acknowledgement. Now the receiver, the physical layer of the receiver, the moment it receives the bit stream, it is going to give the notification to the receiver data link layer. Then receiver data link layer will accept the frame, verifies the address. If it belongs to the receiver, then so it is going to verify whether the frame is damaged or any errors are there in the frame. So it is going to verify. If there are any errors in the frame or the frame itself is damaged, then immediately the frame will be discarded there itself and it does nothing. Simply, the moment the receiver data link layer finds that there are errors in the received information or the received information is having damaged, then simply the frame will be discarded at the receiver data link layer and it does nothing. Okay, simply it is going to be ID, not going to send any confirmation. So by the time the sender, after sending the frame, it has started its timer. Now the timer becomes expired. The timer is going to be expired because receiver, the moment it encounters errors or a frame is damaged, so does nothing, so no confirmation. As a result, the sender will not get any confirmation from the receiver. So it's naturally its timer gets expired. So once the time's out, then so the sender will think that whatever frame it has sent earlier is not reached the destination. That is why the destination has not sent any feedback. So by thinking that way, the sender will retransmit the same frame again. It is going to retransmit the same frame again. Now, suppose a receiver has received and everything is okay. Everything is okay. Now receiver will be sending the acknowledgement. But that acknowledgement is not arrived in time. Not arrived in time. Then or not at all arrived. So till the timeout, if acknowledgement is not received, not reached the sender, then the sender is going to retransmit again. Okay, so that is another case. In the third case, sender has received the acknowledgement from the receiver, but that acknowledgement is damaged, is unable to recognize that acknowledgement. Then again, so transmitter is going to retransmit. Again, the transmitter is going to retransmit the same frame again. So as a result, receiver is getting another copy of the same information, because already earlier it has received and it has sent the acknowledgement, but that acknowledgement is not reached the sender, or it reached but damaged. So as a result, again the sender is sending the second copy of it, retransmitted. So as a result, now the receiver will get two copies. Earlier one copy got and processed, handed over to the network layer and responded with the feedback, that is acknowledgement. But again, due to damage of the acknowledgement or late arrival of the acknowledgement, sender has retransmitted. So second time also the same information the receiver has received. Okay. So now the receiver can identify that is a duplicate with the help of sequence numbers, acknowledgement numbers. So that is why noisy channel, both sender and receiver will use sequence numbers and acknowledgement numbers to avoid duplicates. So because sender has sent this second time, because of, so acknowledgement is damaged or acknowledgement is not received. That is why it has transmitted again. But at the receiver side, if receiver is maintaining that sequence numbers and acknowledgement numbers, then it will recognize, by seeing the sequence number, receiver will recognize it is a duplicate. So immediately the duplicate will be discarded, but it is going to acknowledge that it has received, so that the sender will not send it again. If so, because of the duplicate, if receiver doesn't respond to it, then sender may retransmit again third time, fourth time, fifth time likewise. So that is why, to avoid multiple duplicates, the receiver will acknowledge and it is going to send the acknowledgement, then duplicate will be discarded. So this can be possible only if both sender and receiver are maintaining acknowledgement numbers and sequence numbers. So that is what is being done in the stop and wait. So any of these three protocols, this is being used. So if you see this diagram, this is the sender side and this is the receiver side. So sender side, more or less same, minor differences between the previous diagram and this. If you closely observe, there is simple minor differences. So first let us discuss about the flow of information or frames between the sender and receiver. Then we'll come back to the differences that we are going to identify. So first, the moment the sender's network layer is ready with the data, it is going to request the data link layer for transmission. Then the data link layer will accept the data coming from the network layer. Then it is going to prepare the frame. So whatever is coming from the network layer is being kept as data part or payload part of the frame. Then it is going to attach the header part consisting of physical address of sender and receiver and the size of the frame. Then it is going to adopt a particular error checking mechanism. So whatever error checking mechanism is adopted, so about that it is being including in the trailer part. The frame is ready. So this frame is being handed over to the physical layer. Now physical layer will send this frame as bit stream. So after handing over the frame to the physical layer, now it is going to turn on its timer and waiting for the confirmation. So timer will be on, waiting for the confirmation. Now the bit stream will go. So this algorithm is indicating in this. So if there is a request from the network layer, the data link layer will accept that. After accepting, we'll convert that information into the frame. The frame will be handed over to the physical layer and timer will be turned on. Then waiting for the acknowledgement. So that is waiting for the notification from physical layer, nothing but about the acknowledgement. So that is what is happening at the sender system. Now the bit stream will go to the destination. The moment the destination physical layer receives the bit stream, it is going to give the notification to the data link layer. The moment the data link layer gets the notification from the physical layer, now the data link layer will accept the frame. After accepting the frame, immediately it is going to verify whether that frame belongs to this receiver or not by verifying the physical address of the destination field and the physical address of its system itself. If it is a matching, then the frame belongs to this. Now, so whatever error checking mechanism is used in the trailer part, by using the same error checking mechanism, it is going to verify whether the received frame is okay or not. If the receiver frame is okay, then that information will be handed over to the network layer. Then it is going to prepare the frame, including the sequence number. So whatever sequence number is there, so according to that sequence number, it is going to make the acknowledgement ready, and that acknowledgement will be sent on to the physical layer. Now physical layer will send the acknowledgement in the bit stream back to the sender. The moment sender receives the acknowledgement, so it is going to stop the timer. If timer is not expired by that time, so it is going to stop the timer, and if the acknowledgement is positive, then whatever the previous frame is there in the buffer will be removed, and next to data that is coming from the network layer will be made again next frame that is being transmitted again. So this is how the sequence. Now while it is sending, suppose the sender has sent. This is what we have already discussed in the previous case. Now the differences, if you observe, so one thing is the timer, then second is, so the moment this is sending the frame to the physical layer, so it knows which frame has sent. Suppose this frame has sent now. The next frame to be transmitted is this next even frame. So first even frame, frame 0 is even, then frame 1 is odd, frame 2 is again even, frame 3 will be odd, frame 4 even, likewise. So even and odd frames. Suppose just it has transmitted this odd frame. So next frame to be transmitted will be even. So it is going to indicate the next frame to be transmitted. So that means current frame is this. So even a copy of that will be stored in the buffer, because if at all the sender receives a negative acknowledgement, or if the timer expires, same thing is to be retransmitted. So for that reason, the current frame whichever is already sent is being stored in a buffer till it receives the positive acknowledgement. Okay, that is another difference what we are observing compared to previous. So here the receiver, the moment it has received the frame and frame doesn't have any errors, so it is going to make note of it. The received frame is this. So next expected frame is even. So odd frame is received. So next expected frame will be even. Then it is going to send the acknowledgement for even. So I want next even frame. That is the meaning in this particular. So that is how it is going to mark. So which is the expected frame? Which is the next frame to be transmitted at the sender? So which is the next frame expected by the receiver? So that pointers will be used to indicate what is the current frame received and what is the next frame to be received. That information in this. So Rn indicates the next expected frame to be received. Sn indicates next frame to be sent. So sending frame yes, receiving frame R. That is how the information is being maintained with sequence numbers by both sender and receiver. So if they are maintaining the sequence numbers like this, now duplicates can be avoided. Suppose now this odd frame is received, next expected is even, and it is sending the acknowledgement for even, but this not yet arrived this. So timer expires. Timer expires. Now the same frame, odd frame, this odd frame is retransmitted. Now the same frame will be arriving at this point. Now it is going to see the sequence number is odd, but expected is even. So it will think that whatever is received is duplicate. So again, the same acknowledgement it is going to pass. I want even frame. So that means odd is okay. If I'm expecting, suppose I have received frame number 2. So next acknowledgement if I am sending 3 means I have received 2, okay, I am expecting 3. That is the meaning of this acknowledgement numbers. Okay, so depending on the requirement, some protocols at the receiver will inform the sender that I have received so and so frame. I have received so and so frame, okay. That is received number. Then sender will send the next frame. And some protocols, receiver will send, I am expecting so and so frame. Means before that is okay. Suppose I am expecting frame number 5. Means frame number 4 is received, okay. So that is how depending on the requirement, some protocols will work on expected frame number as the acknowledgement number. Some protocols will use received frame number as acknowledgement. So that is how. Now it is expecting even frame. So it is sending that acknowledgement, but that acknowledgement is not arrived. So it will think that, so whatever odd frame it has sent earlier is lost somewhere. So the same will be repeated. The moment it receives the previous odd frame, but expected is even, received odd means duplicate. So that's how it is going to identify the duplicate. Then again the same acknowledgement is going to send back because I want even. So already odd is okay. So then if that even acknowledgement is received, then so next even frame it is going to make it ready, and that even frame will be sending by the sending data link layer will send this even frame, and its pointer will be adjusted to next odd frame to be transmitted. Okay, so likewise the pointers will be advanced one by one, okay, to indicate what is to be sent next or what is expected next likewise. So this is how this protocol is being operated with this. So in the next slide we will see in terms of algorithm the same concept, the same information we will be discussing in terms of algorithm. Hope everyone understood so far. Okay, now this is the algorithm part for the sender side. Then we will see the algorithm at the receiver side also. So this is the algorithm at sender side. Wait for event, that means acknowledgement. Once it is there, so now this event is request to send coming from the network layer. If there is a request from the network layer, immediately what this does, whatever network layer is sending, so take the data, get the data from the network layer. Okay, then put it in a frame, make the data with a frame. The frame number is SN, so current frame. Then so here make the frame indicates, meaning of make the frame is, so put the data coming from the network layer as the payload part in the frame and add the headers for the frame like physical and physical address of the sender and receiver and size of the frame. Then error checking mechanism adopted and those details in the trailer part. So that complete the making of the frame. Then store that frame, because if at all the receiver says not received properly, there are any errors, then the same frame is to be transmitted again. So that is for that purpose. So whatever frame is being prepared at the data link layer, that will be preserved for some time. It is being stored for some time, so that if the retransmission is needed, so this will be transmitted again as it is without wasting any time. No more time is needed for preparing. Simply the same frame will be sent it to be handed over to the physical layer. So for that purpose, the frame is being stored. So this point we have not come across earlier. Then send the copy of that frame. So send frame means hand over the frame to the physical layer. A copy is preserved and a copy is being handed over to the physical layer. Immediately after handing over to the physical layer, start the timer. So before the timer expires, the sender has to receive acknowledgement. So for that, start the timer. Now what is the next frame to be sent? So increment. Increment the current frame so that next frame to be transmitted is Sn. Means the current frame is Sn minus 1. From this, what we can say, now the current frame what is being already transmitted just now is Sn minus 1, because the next frame to be transmitted is being adjusted to pointer is Sn. So the current frame already sent just now is Sn minus 1. Okay, can send will be made false, means it has to be in waiting state. So immediately it cannot send the next frame. So it should be in the waiting state. So for that, can send is equal to false. And wait for the event, that is, wait for the notification from the physical layer about the acknowledgement. So this is the first part of the sender's algorithm. Okay, because why I am saying first part, only the frame is being made and it is being transmitted. So after getting the acknowledgement, if the acknowledgement is negative, what to be done? If the acknowledgement is positive, what to be done? That is the second part of the algorithm. Okay, so in this second part, receive frame acknowledgement. If acknowledgement is not damaged and acknowledgement number is Sn, means expected is this. Expected frame is Sn. Then stop the timer. So purge the current, whatever frame currently is there, Sn minus 1 is already there in the storage. Remove that from the storage, because the previous frame, this Sn minus 1 frame, is received by the receiver properly. So for that reason, it has given the acknowledgement as I have received, I want this. That means Sn minus 1 is okay. So need not maintain that Sn minus 1 again. Okay, need not maintain that Sn minus 1 again. So that will be removed. And can send will be made true, so that next frame will be taken from the network layer. It can be prepared in the previous slide, whatever we have. So that to go back to the previous slide, right? That is, so once can send true, then go back to this. It is being repeated. Okay. Suppose if the acknowledgement is damaged, not arrived, so timeout. If the acknowledgement is damaged or not arrived, then timeout. Once it is timeout, start the timer, send the same frame again, whatever is there in the storage, send that frame again the start timer. So either same frame is to be transmitted, or else fresh. If this is the case, go to fresh frame, take the fresh frame, prepare it and send it. If the acknowledgement is damaged or acknowledgement is not arrived, then timeout. Once it is a timeout, so again send the next frame and start the timer. Wait for the acknowledgement. So this is how for every frame the sender will be taking place, or sender will be doing the task. Okay, so send the frame and wait for the acknowledgement. If there is no acknowledgement, repeat the same. If there is acknowledgement, so if that acknowledgement is okay without any problems, then stop the timer. So remove the existing frame from the storage or from memory or buffers. Then fill the buffers with the next frame. Then send the next frame. So this is what the sending data link layer does.